my name's Mike Morrison. I am Director of Recreational Training for a company called Overland Experts. All right, so we're gonna move right into it. And if I get to talking too fast, because I get excited, just tell me to slow down. And you'll have to excuse me, I got a little cold, so my voice sounds a little scratchy. But we run on a 5 systems curriculum, and it's a linear curriculum. So each additional system builds on the last. So this is a process, basically taking what people do when they drive off-road, people who have driven for years off-road and are good drivers. We took the process that they go through in their head and we applied it to a curriculum so that you can understand it and you can learn from it. So as you're driving, this is something you want to kind of go through when making a plan, when looking at an obstacle and picking a line. So our first system is differential. So all of our 4-wheel drive vehicles have at least 2 differentials on them. There's one in the front axle and one in the rear axle. Sometimes our full-time 4-wheel drive vehicles will have a 3rd differential, but that's a little later in the curriculum. But our 2 differentials, they serve a main purpose. Who can tell me what that purpose is?
Compensate for the difference in the rotation and speed of the right and the left side or whatever.
That's exactly right. So differentials, their job is to differentiate the power left to right. So when we turn our vehicle, because it has 4 tires, all 4 tires follow a different path. They're different distances. So they have to be able to turn at different speeds, or if you've ever heard a vehicle on pavement that has a welded rear differential turn, they just chirk tires the whole time they turn. And for our vehicles, because we drive them on pavement quite a bit, that would cause a lot of wear and tear. So that's where the differential comes into play, to differentiate that power left to right. Pieces and parts in a differential, we've got a pinion gear that comes in the back. Our drive shaft would come in here. Pinion gear comes in the back. As the drive shaft turns, it turns that pinion gear. That pinion gear in turn turns this ring gear that we have right here. This ring gear is mounted to a carrier. Okay, inside of this carrier we have what we call spider gears. Okay, top and bottom are our spider gears. On the sides we have what we call side gears. Now when we're driving straight down the road, everything turns at the same speed. But when we start turning and a tire feels resistance, those spider gears and side gears start to slip, allowing one side to turn slower than the other. Now, this is your standard open differential, okay? Not a limited slip and not a locking differential, okay? We're just gonna cover open differential today. So our axle shaft's coming out the side right here, so you can kind of see how they change, and it can happen with either side. As it feels resistance, that slippage can happen. Now, how does that affect us off-road? Where's our power going to go? Tire with no traction. It's just like water. It follows the path of least resistance. So if we have a tire in mud and a tire with traction, that tire in the mud is going to spin. Or we have a tire in the air and a tire with traction, the tire in the air is going to spin. And if one tire in the rear breaks loose and starts to spin in our vehicles, and a tire in the front has to spin. So do we really have 4-wheel drive vehicles? No, they're 2-wheel drive vehicles. One tire in the front and one tire in the rear will spin. So how do we overcome this when driving off-road? Okay, we can have lockers, we can have limited slips, but those are mechanical things our vehicle does for us. What can we do as a driver? So we have a way of becoming our own locker or traction control for the vehicle, and it's called 2-foot driving. So how do we 2-foot drive? So left foot with an automatic drives our brake. Our right foot drives our throttle. So the way we drive with 2 feet, we set the brake and we set our throttle. We pick an RPM based on the weight of our vehicle, the terrain we're on, the obstacle we're trying to climb. Normally, standard obstacles, we may be around 1200 RPM, so we set that RPM and we forget about that right foot. We keep that RPM pretty much the same. Then our left foot is how we control our movement. So we're using the brake to move. What that does, as we use that brake to move, is keep resistance to all 4 tires. Very similar to how the traction control systems in our vehicles work. Other than we can only control all 4 brakes at a time, traction control can control 1 brake at a time. But we're still keeping resistance to all 4 tires. Sometimes it takes more resistance, sometimes less resistance, but that comes with experience. And kind of learning the RPMs we need comes with experience as well. So when we're driving and we come up to an obstacle and we need more momentum, we start to let more out on the brake. When we need less momentum, we apply more brake, but always keeping that throttle pretty much the same. A trick, so you've got your transmission tunnel and your throttle here, is to take your right foot and the corner of it, wedge it in, and then roll it onto the throttle. If we roll it onto the throttle and keep it wedged against the transmission tunnel, then as we're bouncing around off-road, our foot's not going to be bouncing up and down and moving our throttle a whole lot. Now, especially with newer vehicles, the reason for that consistent throttle is because now instead of a throttle cable with an older vehicle like your Bronco, our newer vehicles like our JK have a little sensor that talks to another little sensor that tells the computer how much we're pushing the throttle. And it's extremely touchy. So every time that we manipulate that throttle or bounce our foot on that throttle, we engage kind of like stomping on the ground. So we're really putting a lot of effort right into one quick movement to our tires, okay? So it's slack, engage. Kind of like if I'm walking up a muddy hill and I'm stomping up the hill, probably I'm gonna fall. Same concept, so if we're stomping on that throttle or manipulating that throttle, our tires are stomping on the hill. So they're breaking loose, and that's how we create a spin situation, and we lose our traction. So with that 2-foot driving on an automatic, we can maintain that traction. Now a manual gets a little bit trickier. How many manuals do we have today? Awesome. I love a manual though. I feel like I have so much more control. So with a manual transmission, very important how we take off in 4-wheel drive low range. We start to let out that clutch until it hits the friction point. Then we come off the brake with our right foot, the rest of the way off our clutch. So the vehicle's now moving. We shift our feet over so that our right foot's on the throttle and our left foot's on the brake. Now we don't have to apply throttle a whole lot with a manual because it's moving, right? Depending on our gears and size tires, we may have to apply some throttle. But most of the time, especially with like our Jeep Rubicons or some of our more dedicated trail rigs that have a really low crawl ratio, we can just manage that brake. And same thing. So we can take that vehicle by applying the brake and take it almost down to a stall and really slow it down and keep resistance to all 4 tires. And then we really don't have to worry about that throttle a whole lot. And then when we have to stop, take our feet off, shift them over again, right foot brake, left foot clutch, hard on the brake, and then push your clutch in. So what that does, and the reason we use the brake when using our clutch, is because that clutch completely disconnects our drivetrain, right? So if you see the guy, he's off-road and he's trying to climb a rock and he makes it about halfway up and stalls, he pushes his clutch in right away and rolls off. That's why we manage that brake. We want to limit that rollback, okay? So remember, taking off, let out the clutch to the friction point, off the brake, then off the clutch, then when stopping, brake, then clutch, okay? Now, manual transmission, years ago, people with manual transmissions were running over cats, dogs, garage doors. So in the United States, the Vehicle Safety Commission decided you can't start a vehicle anymore without having the clutch engaged. Toyota got really smart and they gave us a little button so we could do what they call a clutchless start, where you turn the key and the vehicle starts in gear. It starts moving right away, just starts crawling right along. Jeep, on the TJ, you had to replace a fuse. On the JK, when it goes into 4-wheel drive low range, you can start it right in gear. So you just turn the key and that starter motor will start turning those tires and cranking that motor until the motor takes over, and it's moving right along. One of the greatest tools off-road. So our philosophy is, and this comes from some experience, I don't want to replace a clutch off-road. So that's why we tend to get away from it and move over. Scott, my mentor and the trainer we were talking about earlier, he always said, no touchy the clutchy, right? He'd tell the military guys, he'd say, no touchy the clutchy, because I don't want to replace a clutch off-road, and that's a wearable item. So every time we're slipping that clutch or using that clutch, it's wearing out, right? Because it's a flywheel and a clutch plate creating friction, and we can even glass it and make it less effective. So once we start moving, we forget that clutch exists. We're only using that clutch to start and stop, and that's going to be hard.
Real hard.
It's going to be real hard to forget about it. But if we stall and we start again just using the clutchless start, the only two items we're wearing out is a battery and a starter. Okay, super easy to replace a battery off-road. And with a manual, we can just push start it. Starter, same thing. We can push start it, or we can replace a starter off-road. Replace a clutch, we're doing a whole lot more. So that's kind of the thought process behind kind of forgetting that clutch exists. So that's how we overcome the differential with that 2-foot driving. Now, it is increased wear and tear on our vehicle. Okay, with our manual transmissions, we're wearing out the brake, right? A little bit more on the starter and the battery, a little bit more wear and tear. With our automatic transmissions, it's increased heat on our brakes and our automatic transmission. So we call it type A driving when we're driving 2-foot. It's aggressive driving. And then normal driving is just your type B driving where you just 1 foot back and forth. So we only use type A driving when we're on technical obstacles. That way we don't cause excessive wear and tear on our vehicles. So when we're just driving down the trail and there's not an obstacle for us to worry about, we can go back to that type B driving, let everything cool back down. Then we get to that rock climb or that hill climb or those moguls, and we go back to that type A driving. So any questions about differential or 2-foot driving? So our takeaway for differentials is drive the weakest wheel. So when we're picking our line, we want to look and see what's going to be our weakest wheel. What wheel is going to spin? And that's our weakest wheel, and that's what we want to drive.